Hello friends, here in this video we are going to see a problem on pentagonal pyramid. Here is the question. A pentagonal pyramid, base 30 mm side and height 65 mm, stands on its base on HP with an edge of base parallel to VP, a section plane perpendicular to VP, inclined at 45 degree to HP, bisecting the axis of the pyramid. Draw front view, sectional top view and true shape of the section. So this is the question in front of us. Whatever the conditions are there, I'll explain it step by step. First, by reading it we understood the type of solid. So I'll draw the diagram of a pentagonal pyramid and then we will move further in this problem. So here we have a pentagonal pyramid in which the base is in the shape of a pentagon. Here we have a pentagonal base. Then there are 5 corners of the base. Those corners are connected to a common apex O. Then corner to apex, they are joined with the help of the edges, and those edges are slant edges. Then since it is having a pentagonal base, there are 5 triangular faces. And so this is a pentagonal pyramid. Now the question given is pentagonal pyramid, base 30 mm side and height 65 mm. It means the base side is 30, height is 65, stands on its base. Its base means the pentagonal base on HP. So here in this diagram I can say that the pentagonal pyramid is resting in HP. HP is also called as ground. So when the pentagonal pyramid is resting on the ground, in that case from the front we are going to see the triangular faces, whereas from the top we are going to see the pentagonal base. Now the condition is, since it is resting in HP, then top view will be visible in HP and front view will be in VP according to first angle method of projection. And here the condition is with an edge of base parallel to VP. So how that is made, how that edge is made parallel to VP, I'll explain it in the question. And so here when we have understood this much, we can easily start the solution. So in the solution part I'll explain these conditions, that is edge of base parallel to VP. So let us get started. Now in the question it was given that a pentagonal pyramid is resting in HP with edge of base parallel to VP. So for that I can draw the pentagon in this way. Drawing a light line, the side of the pentagon is 30 mm, measuring 30 mm. The base edges of the pentagon are inclined at 72 degree. Drawing light parallel line, and here also light line. Next, I'll measure this side, which is 30 mm. Mark it on one side, on the other side. Then drawing an arc, cutting it from the other side, and where it intersects, here I will get the point, joining it. Next, I'll mark the apex for this pentagonal pyramid, and for that I am going to take the midpoint of any one of the side, join it to its opposite corner. Then I'll take the midpoint of any other side, joining it to its opposite corner. So wherever these two lines intersect, that will give us the apex. Here I'll give the notations. Then joining these 5 corners to the apex. Now, after getting the top view, I'll project the front view of this pentagonal pyramid. Giving the notations, this is 1 dash, here we have 5 dash, 4 dash, this is 2 dash, 3 dash. So in the problem it was given that pentagonal pyramid is resting on HP with an edge of base parallel to VP. So that edge of base which is parallel to VP is edge 4 to 5. Now I would have even drawn this pentagon in this way, that 4 to 5 would have been at the bottom or this corner 2 at the top. That is also correct. In that way also an edge is parallel to VP. So either I can make that edge closer to XY or away from XY, it will remain parallel to VP. Now the height is given as 65 mm. So this is the apex which we are seeing from top, it appears as a point, but when we are looking from front it will be a line. (65 mm). Then that is point O dash, joining them with the help of light lines to the apex, that is the corners, 3 dash, then 4 dash, (5 dash) and 1 dash. Next, after getting the front view of this pentagonal pyramid, now I locate the cutting plane over it and then draw it dark, because without locating the cutting plane we cannot make this dark, because we don't know which part is to be retained and which is to be removed. So for that, here it is given that a section plane perpendicular to VP inclined at 45 degree to HP. Inclination with HP is given, that is theta. Now this inclination will be visible in VP. So inclined at 45 degree to HP, bisecting the axis of the pyramid. So here if we see, the axis of the pyramid is of 65 mm long. I'll take half of that. Drawing a light line through it. So the cutting plane is visible in the front view because inclination with HP will be seen in VP. So inclined at 45 degree. Drawing a light line through it. Now this is the cutting plane, and I have to see that which portion is to be removed and which is to be retained. Since this is the front view and we are seeing the sectional plane in the front view, now when this pyramid is cut in the front view, we are going to see the sectional top view, and for that here is the observer. So when the observer is at the top, that portion has to be removed which is closer to the observer. So if I see here, the part of the pyramid which is on the other side close to the observer, this top portion will be removed and bottom portion will be left or retained. Here I'll draw the cutting plane line. Cutting plane A dash. So I'll make dark whatever is retained. Now, so here I'll be making it dark. Now if we see from in this direction, that is we are going to project the front view by seeing the top view in this direction. Now from this direction, points 4 and 5, that is this edge 4, 5 is not visible. So it means it should be hidden. So the edges 4 to O and O to 5 will be hidden. So here I'll make this dotted because it is not visible to the observer. So it is a hidden line. At the same time, from 5 dash to O, that is also hidden. Now, this is the sectional front view. We can say the front view in which there is a section plane. Now, looking at this front view from the top, we are going to project the sectional top view, and for that I'll explain it. Now the cutting plane is cutting edge O dash 1 dash, the slant edge at this point. I'll say it is point A dash. Then it is cutting O dash to 5 dash at this location. I'll say that is B dash. Next, cutting two edges at the same time, that is 2 dash and 4 dash. Here we have 2 dash. Okay, only a single edge is cut, O dash to 2 dash. So I'll say that this is C dash. Where it is cutting O dash to 4 dash, I'll say that is D dash, and where it is cutting O to 3, I'll say it is E dash. So in total we need to project these 5 points in the top view. So starting with A dash, A dash will lie on the slant edge O dash 1 dash. So on O to 1, we have a point A, then B dash is on O dash 5 dash, so point B will be projected on O to 5. Then here we have C dash, and this C dash is the point which we are getting when O dash 2 dash is cut exactly at the center. Now this point will not be projected directly down, because where it will cut, that we do not know. For that I'll have to project C dash onto the slant edge, like with a horizontal line here. Next, from O dash I am drawing a light line. Now this point C dash will be projected down. So it will be projected up to this horizontal line. Now here C dash is on O22 because it is cutting O dash 2 dash. Measuring this distance in the compass from the apex point O up to here and marking it on O22. Here I am getting point C. Then D dash is on O dash 4 dash, that is on O24. So where it is cutting O24, that will be point D. Then E dash is cutting O dash 3 dash, so it will be projected on O23. So we are getting point E. Now connecting these points in the proper sequence, joining A to B, then B to D, from D to E, E to C, C to A, so this is the shape which we are going to get when this pyramid is cut and we are looking from top. Now making it dark, then this entire pentagonal base is visible from top view. Then A dash 1 dash is a continuous line, it is retained and visible from the top. So here I will connect A to 1. Next C to 2, C dash 2 dash is also visible. Then E to 3 is visible. D to 4 is visible. B to 5 is visible. Next, I'll draw the section lines over here. Measuring an angle of 45. Drawing section lines. Now, after getting the sectional top view, I'll draw the true shape of the section and for that I will have to make this cutting plane parallel to XY line, and this true shape will be on this side because it is in HP. So drawing a light horizontal line here. I'll measure the distance where the cutting plane is in contact with the pyramid, that is A dash to E dash. E dash, here we have E dash. Then from A to D, so we have D dash. Now after measuring the distance from A to D, I'll take the distance from A to C, A dash C dash. Then A to B. Now projecting these points in the top view step by step. So starting with A dash. Drawing a light line. Here we have point A. So wherever A dash and A they intersect, that will give me the point A. Then B dash and B. So here B dash and this is point B, where they intersect, that will give me point B. Then C dash. And here point C. So where C dash and C they intersect, that will give me point C. Then point D. So wherever D dash and D they intersect, that will give me point D. At last point E. So E dash is projected light. And here we have point E, where they intersect. That will give me point E. Now joining all these points in the sequence with the help of light line first. So joining A to B, B to D, D to E, E to C, and C to A. Now after joining these points, light, I'll make them dark. So this is the true shape of the section. Then I'll make this cutting plane dark. Then here I'll give the viewing direction, that is cutting plane AA dash. This is the true shape of the section. Next, after getting the true shape of the section, I'll give the dimensions. Here the base edge is of 30 mm side and the axis height is 65. So after that I'll give the dimensions to the axis. It is 65 mm long. Then after giving the dimensions to the axis, I'll give the dimensions to the cutting plane, and if we see here in this problem, the direction of the cutting plane, it is given that it was inclined at an angle of 45 degree to HP, and that was seen in VP. So here I'll say this is the inclination of the cutting plane with HP and it is seen in VP. So this is the inclination of the cutting plane, and with this we complete the problem.